back to Maths with Myra, where quick steps and easy to follow solutions are how we roll. Grab your pencil, let's get started. It's the first part of the first two-parter. So since it's a special occasion, we're switching from the 2025 paper to the 2024 paper. And along with that, we're going to do a lot of questions today. Questions 1 to 12 in fact. In the next video, we will do questions 13 to 25, but we'll deal with them later. 5 expressions below are simplified. How many different values are obtained? We have the same rules as every other video. Your 3 seconds starts now. Okay, in our question, a keyword here is different. So we can't just do our answers straight away as 5 because there are 5 equations. No, because some of them probably will be the same, which is the trick to this one. It's the first question, so the way of solving this will be simple. You just need to solve each equation. 2 plus 2 is 4, 2 times 2 is also 4, 2 minus 2 is 0, 2 divided by 2 is 1, and 2 squared is also 4. 2 squared is the same as 2 times 2. So as you can see, 4, 4 and 4 are the same. But 4, 0 and 1 are different. So there are only 3 different ones in total. Question number 2. Which of the following could have a capacity of 10 liters? I'll give you 3 seconds to pause the video and answer the question. Then we'll go through it together. This is just an estimation question, so in order to answer it, we'll need to use process of elimination. An aeroplane. If you've ever seen an aeroplane, they are massive. 10 liters, 10,000 milliliters, is just a tiny grain of salt in an airplane. A cup. You know those glass cups you get at IKEA? Yeah, those are absolutely tiny. Remember, 10,000 milliliters is what we're talking. A dustpan. Dustpans, if you've ever seen a dustpan, you'll know that they can't even fit 1 liter of water in them, let alone 10. And an egg, absolutely tiny. No way 10 liters is going to fit inside of that. By process of elimination, B, a bucket. Jill is 36 this year. In which year will her age next be a square? You have 3 seconds to answer the question. Okay, now, Jill is 36 this year. Now, this is a 2024 paper, and if they mention this year, think of it as the year that they took the paper in. And I know it's 2025 right now, but this year would be 2024. Now, she was 36 in 2024. 36 is 6 squared, or 6 times 6. So the next square number will be 7 squared, 7 times 7. And 7 times 7 is 49. Now 49 minus 36 is 13 years. 2024 add 13 years is 2037. Her age will next be a square in 2037. A drink is made by mixing 1 part of cordial with 4 parts of water. What percentage of the drink is cordial? You have 3 seconds starting now. Okay, now, if we think of it as a ratio, for every 1 part of cordial, there is 4 parts of water. Then, ratios can often be turned into fractions. So, 1 part plus 4 parts is 5 parts. So the denominator, total amount of parts, is 5. The cordial is 1 part out of 5. And the water is 4 parts out of 5. But we don't need water right now because we're only thinking about the percentage of cordial. We need 1/5 as a percentage, which is, if we find the equivalent fraction, multiply the bottom by 20 and the top by 20, we get 20 over 100, which, as we know, when you want to put it into percent, you take the numerator when it's on top of 100. There we go. It's just 20% of the drink is cordial. This is the value of 1 plus 2 minus 3 times 4 divided by 5. Now, you have your 3 seconds starting right now. Okay. Remember, BODMAS or BIDMAS. Well, in advanced BODMAS, we're going to have to group multiplication and division, and addition and subtraction. Let's say 1 plus 2 minus 3. You could do 1 plus 2 and then minus 3, or you could do... Basically, you have to do them in the order that they appear, not one before the other. Despite the fact that it seems like addition should be before subtraction. But if we also look, are there any brackets in our equation? No. Are there any indices or orders in our equation? No. But there is a division and a multiplication. 3 times 4 divided by 5. We solve that first. 3 times 4 is 12. 12 divided by 5. Now, if we keep that as a fraction, we get 2 and 2/5, which is 2.4. Not that hard. So you don't have to go straight into decimals. You can take it into a mixed number and then put it into decimals. And the fraction is easier. Okay. Now, we can solve the addition and the subtraction. So right now our new equation is 1 plus 2 minus 2.4. If we do it in the order they appear, that's 1 plus 2, 3, minus 2.4, which is 0.6. Our answer is E, not 0.6. The following has the same remainder when divided by 3 as it does when divided by 4. Your 3 seconds starts now. Okay, so we just need to do a bit of elimination. 7, when divided by 3, gives us 2 remainder 1. And when divided by 4, you get 1 remainder 3. These are not the same. 11, when you divide by 3, you get 3, which is 9, remainder 2. Is it the same? No. Is the remainder of 2 the same as 2 remainder 3? Nope. I'm seeing the pattern, but I can't be seeing this pattern because there's no way any multiple that's not a multiple of 3 has a remainder of 3. So we have 17. Maybe that will break this pattern that I'm seeing. When it's divided by 3, I get 5 remainder 2. When I divide it by 4, I get 4 remainder 1. It broke the pattern, just not in the way I would like it to have done. 19, 6 remainder 1. Is it the same as 4 remainder 3? I'm afraid not. So, by elimination, 25 is our only possible answer, but let's check it. Because if there was like an explain your answer at the end, we would need to know. So, 8 remainder 1 and 6 remainder 1. Another way you could have done this is you could have looked at any numbers that are close to it that have multiples of both 3 and 4. But I feel like this is a better method of just listing out the remainders. Also, it makes sure I don't miss anything, and of course my answer is E. The diagram shows a large square which has been divided into 4 smaller squares. It also shows both diagonals of the large squares and 2 diagonals of smaller squares. What fraction of the area of the large square has been shaded? Your 3 seconds starts now. Okay, what we need to do is first look at the shaded part. So we realize that each square can be divided into 4 tiny little triangles. So we divide each square into 4 tiny little triangles. So now we have 16 tiny little triangles. By tiny little triangles, I mean that. So, now that we have all that, out of the 16 tiny little triangles, there are 1, 2, 3, 4, 5, 6 that are shaded, which we can simplify to 3 over 8. So answer is D, 3 over 8. Guy has half as many pets as Aisha. Aina has twice as many pens as Sky. What fraction of all their pens does Sky have? Seconds on the clock. Okay, so we have to do a little bit of algebra here. Let's say the amount of pens that Sky has is P. And since she has half as many pens as Aisha has 2p, double the amount that she has. And Aina also has double as many pens as Sky, so she also has 2p. And if we add all this together, we have 5p. The amount of pens that Sky has is p out of the entire 5p. We could say p is the same as 1p. 1p over 5p. All we have to do is just simplify. Get rid of the p's. And our answer is 1/5, aka C. The diagram shows the regular hexagon PQRSTU. What is the size of angle UPT? 3, 2, 1. Okay, so because it's a regular hexagon, all of the sides are equal, which we'll mark using these lines. Next, when we look at angles, P is a side, but then P needs to somehow connect to T. So you have to draw a line, a straight, hopefully, line. Imagine it's straight. That goes from P to T. And since UPT, we're looking at this angle. Well, because it's a hexagon, we need to apply formula. We need to apply n minus 2 times 180 divided by n to get one internal angle, aka this angle that I'm drawing in. So if we substitute the values, we have 4 times 180 divided by 6. We can cancel these two and get 4 times 30, which gives you 120 degrees. So PUT is 120 degrees. Next, because PU and UT are the same length, our triangle that we've made is isosceles. Opposite angles are equal. So 180 minus 120 is 60, which is the sum of UPT and UTP. And since those two angles are the same, we need to half 60 to get our angle that we would like, which is 30 degrees. Our answer A, 30 degrees. Threads field, there are some humans and some horses. There are 25 heads and 60 legs. What is the difference between the number of humans and the number of horses? Now, your 3 seconds starts now. 1, 2, 3. Okay, this one's a little bit difficult because you have to really pay attention as it's hard to explain. So, a human obviously has 1 head. Imagine a human with 2 heads. That's weird. And a horse also has 1 head. Pretty much every animal has 1 head. Actually, I think all animals have 1 head. So because there are 25 heads, there are 2 heads, there would be 2 humans and horses. There are 25 heads, so there are 25 creatures. And 60 legs. Now, a human has 2 legs and a horse has 4 legs, right? So, let's assume we're going to make a hypothetical scenario that there are 25 humans. There are 25 humans, there would be 50 legs because for each human, there is 2 legs. But, unfortunately, that is 10 less than what we want. So, those 10 legs must come from the horses. But this is where it gets slightly more difficult. And this is the part where it might catch you out. You may be thinking, but you can't do 10 divided by 4. That's impossible. Well, it isn't, but you get a decimal, and I can't be a decimal number of horses. What we need to do is figure out horses have 4 legs and humans have 2. The difference is 2 legs. And we can do 10 divided by 2. That's 5. There are 5 horses in the field. So, there are 20 humans and 5 horses. Let's check. 20 humans, that's 40. 5 becomes 20. Add them together and you get 60. That actually works. So, 20 minus 5 is 15. Hence, E is our answer. Hexagon is formed by arranging 3 equilateral triangles, as shown in the diagram. The side length of the largest equilateral triangle is 10 centimeters. What is the perimeter in centimeters of the hexagon? Your 3 seconds starts now. Okay, so the largest equilateral triangle is obviously this one. And the side length is 10. So 10, 10, 10. Then the side length of this and the side length of this has to add up to 10. So let's take that as 6 and that as 4. It doesn't really matter as long as they add up, because this is also 6 and this is also 4. Using our number bonds, we realize that no matter what, these two sides must add up to 10, and these two sides must also add up to 10. And these two sides add up to 20. So, 6 add 6 add 4 add 4 is the same as 5 add 5 add 5 add 5. The same as 7 add 7 add 3 add 3, 20. And of course, 10 plus 10 is also 20. No matter what we assumed the side length of the other two triangles to be, we get the same result of 40 centimeters. It's rarely ever more information needed. So if you see that, expect that there's going to be a trend. Last question. In the multiplication sum show, y represents the same digit each time. What is the value of y? Now, because it's the last question, you don't even have to work it out. I'm going to work it out for you. Y times y is the same thing as y squared. And y squared ends in y. So y could either be 0, 1, 5, or 6. Then we look at our numbers up here. 3y, it isn't 3 multiplied by y, it's a number. The 10th digit is, so it's sort of 30y, like 31, 32. So it must be greater than or equal to, because remember, zeros are the option, 30. And for y is greater than or equal to or 100. The thing is that it has to be greater because of the 770. So 30 times 400 is 12,000. But our answer has to be greater than that. Since y is in the thousands column, it can't be 0 or 1 because it has to be at least 12,000 our answer. So all that remains is to check 5 and 6. If we start with 5, we get an answer of 15,925. And if we try it with 6 though, we get 16,776, which works. So our answer is E, 6. That's the end of part 1. How long is this video? Somebody comment it for me. But I do know that it's probably my longest video yet. And it's only the first part. You understand why I made this a 2-parter? So stick around for the next time, and I hope to see you there.